In this video, we are going to explore basic geometry concepts. In grade 8, we can roughly divide this into three categories. Lines and angles, where we have angles around a point that add up to 360, angles on a straight line that is equal to 180, and vertically opposite angles that are equal. This is the one that looks like a bow tie. Then we have parallel lines. You might know the letters F, U, and N, which spell fun. So when you see the F, that is corresponding. The U is co-interior. They add up to 180. So unlike corresponding where it's equal, these ones add up to 180. And then we have the Z or the N, which are alternate angles. We also have rules about triangles. You might know by now that all the inside angles of a triangle add up to 180 degrees. The reason here is interior angles of triangle. You can also say sum of angles in a triangle. There is also exterior angle of a triangle. That means that this big outside angle is equal to these two opposite inside angles added together. And then this is the one that most people are a little bit confused by, and this is the isosceles triangle. Can you see that these two angles here at the bottom are equal? Because they are opposite the equal sides. Therefore, our reason is angles opposite equal sides are equal. Or if you want to prove that the two sides are equal because the angles are given, you can say the sides opposite the equal angles are equal. Let's start with two easy examples of what we've just learned on the previous page. In our first question, we need to find angle theta. Because we have two of the other angles in the triangle and I need the third one, I can use the rule of interior angles of triangle. I always need to write down a statement and a reason. In this case, the statement will be theta equals 180 minus 70 minus 64. So that means that theta is 46 degrees. Your reason for this will be int angles of a triangle. Let's look at the other question on the right-hand side. Now, you can first work out the interior angles of a triangle and find this angle over here, BCA, and then do angles on a straight line, but that is unnecessary since we can just do exterior angles of a triangle. That means that this big angle X over here would be the sum of 43 and 73. My statement in this case would be X equals 43 plus 73 degrees. And that gives me a value of 116 degrees. Our reason, exterior angle of triangle. So that is why I prefer the int angles of triangle reason, because you have int angles and you have x angles. So here where everything is on the inside, here we have the outside angle, which is equal to the opposite inside angles. In this question, we are also looking for angle theta, and angle theta is in the big triangle BAD. We know that this angle over here is 90 degrees, but I do not have the value of angle D at the bottom. Therefore, I cannot just use interior angles of a triangle. But there is a reason why the 160 is given over here. So that means that I can find angle C2. The other thing that is given that I should be using is the fact that these two sides are equal. Remember that they give you this information for a reason, and there's a very good chance that you will have to use all the little information that is given. They won't tell you that this is an isosceles triangle unless you have to use it. What do we know about an isosceles triangle? That my two base angles are the same, and seeing that I can find the size of C2, it means that D will be the same size. Then once I have D, I can work out the big triangle, ADB, to find the value of theta. You can do all of this on your sketch before you start writing down any statements and reasons. See if you can figure out what information was given and how you can use it in order to find your final answer. Once you've made all your scribbles on your drawing, let's try and set that out in a nice, organized way with a statement and reason for each process. So what did we do first? First, I determined angle C2. And C2 would be 180 degrees minus 160 degrees. So therefore that gives me 20 degrees. And my reason for this is angles on a straight line. Now that I have C2, I can say that angle D is the same. Do you still remember the reason for this? It's because of an isosceles triangle, but we don't write down isosceles, we write down the angles, the equal angles are opposite the equal sides. So we say angles opposite equal sides. Now that I have angle D, I can work in my big triangle and I can find the value of theta. So theta would be 180 degrees minus D, which by the way is 20 degrees, minus 90 degrees, which is that block at A, and that gives me a value of 70 degrees. My reason for this? Interior angles of a triangle. In this question, I once again have isosceles triangles, and angle theta that I'm looking for is in the bottom triangle over here in CBD. So already I know that D2 will be the same as theta, but there are no given angles in this blue triangle. But maybe if I look at the other triangle where they have the 52 degrees, I can find some of the other angles that might help me. So over here, I can see that BD and AD are the same length, meaning that angle A and angle B1 will be the same. And I can find their value because I know that D1 is 52 degrees. So this question, it's actually fairly simple to figure out what the answer is. I have to go through quite a process, but to set it out and give the appropriate statement and reason can be a little challenging. So let's go through the process. I'm going to start by saying that I can see that B1 would be the same as angle A because they are angles opposite equal sides. Once I have said that, I can now use interior angles of a triangle to calculate what they are. So I'm going to say that B1 would equal 180 minus 52 degrees, and then I'm going to divide that by 2. Because remember that A and B1 are the same. And my reason for this would be int angles of triangle. So remember when you have an isosceles triangle, you always have to say angles opposite equal sides and interior angles of a triangle in order to find your answer. So let's calculate this. 180 minus 52, that gives me 128, and half of that would be 64 degrees. Remember your degree sign. I like to write it in on my drawing because it helps just to make a little bit more sense of what's going on. You can either now work out angles on a straight line to find theta, or you can recognize that this angle B1, the 64 degrees over there, is the exterior angle to theta and D2, which I think is a slightly shorter way. Because I'm working with an isosceles triangle, I have to start by writing that down. So I'm going to say that angle C is equal to angle D2, and my reason for that is these are angles opposite the two equal sides. So angles opposite equal sides. So that means that B1 is equal to C plus D, because that is exterior angle of triangle. So that means that theta, which is angle C, would just be half of 64. So theta equals 32 degrees, because remember C and D are equal. So if I write it here on my drawing, these two must be the same, and together they must add up to 64, meaning that each one would be 32 degrees. Another way to make things a little bit more challenging is to put x's and y's and all kinds of variables onto my sketches. This means that you have to know your algebra knowledge in order to answer these questions and find the value of x. So hopefully you've noticed that we have an exterior angle here, this big outside one, and that is equal to the two opposite inside angles. And that is exactly what you need to write down. You have to say that 6x minus 15 degrees is equal to 3x and 2x plus 12 added together. So think back of what you learned in algebra. So we're first going to simplify, so that gives me 5x plus 12 degrees. And on this side, we didn't change anything. It's just 6x minus 15 degrees. So always a good idea to have all your x's on the one side and all your numbers on the other side. So let's do that. So 6x, and I'm going to minus 5x because it was a positive x on the other side. And here I'm still going to have the 12, but notice that this was a negative 15, so therefore I have to add 15 on this side. So 6x minus 5x is 1x, and 12 degrees plus 15 degrees is 27 degrees. So your value of x for this question is 27 degrees. But don't be so excited with solving the equation that you forget to write your geometry reason, and our reason in this case is exterior angle of triangle. Let's see if we can use our similar knowledge of algebra and geometry to solve the next one. So always have a look at what information they give you. So I'm spotting an isosceles triangle here. So let's have a look. What does that mean for my drawing? It means that this angle over here, D1 and C1, will be the same because my base angles are the same in an isosceles triangle. So I'm going to write that in on my drawing to see if it makes a little bit more sense. And now I have all the angles inside the triangle in terms of y. So that means that 2y plus 5y plus 2y must equal 180, because that is the sum of all the angles of a triangle. Because it is an isosceles triangle, we need to write down two reasons in this case. So let's start by writing down that C1 is equal to D1, and you can even write that it's equal to 2y. And my reason is it's the angles opposite the equal sides that are equal. So angles opposite equal sides. Once I have written this, I can now say that 2y plus 2y plus 5y equals 180 degrees. And my reason for this is interior angles of a triangle. So that means that 9y's equal 180. So 1y equals 20 degrees. Now that I have y, it should be easy enough to find x. So let's have a look. I actually have another isosceles triangle here. So let's have a look over there. Oh, and it looks like very much similar to the previous question. I have the exterior angle, which is equal to the sum of the two opposite interior angles. But remember, isosceles triangle, I always have to start by saying which angles are the same. So in this case, I have angle E is equal to angle F2, and that would be equal to x. And my reason for this is, once again, angles opposite equal sides. Now I can say that 2y equals x plus the other x, because remember this one over here is also x because they are the same. So if 2y is equal to 2x, it means that y is equal to x. And that means it's equal to 20 degrees. My reason here is exterior angle of triangle. It's now time to have a look at our parallel lines. And once again, I'm going to start off very easy. So in my first one, hopefully you've noticed the F. And the F of our fun is corresponding. So that means that N is 100 degrees. Reason, corresponding angles. And hopefully you remember that I have to write which lines are parallel. In my next one, the letter that I can see here is a N or a Z. So that means that A is 146 degrees, and that is alternate angles. My parallel lines are PQ and RS. In my third example, I have co-interior angles. And remember for this one, they add up to 180. And you can actually even see it on here. This one is obtuse and this one is acute, so they are not equal. Don't accidentally say that they are equal. So A is 180 degrees minus 116 degrees. So that means that A is 64 degrees. Our reason, co-interior angles, and our parallel lines are also PQ and RS. But of course, it will never just be that simple, and we will try and trick you with something like we have here on the right. So here you must be very careful because AB is not parallel to CD. They do not tell you that. In fact, you can even see it. CD looks very skew in comparison to AB. Only EF and MN are parallel. So often they say that we need to find it in alphabetical order. So let's try and do that for this one. So A, we can see is just angles on a straight line. So A would be 180 degrees minus 63 degrees. And that's and that gives me 86 degrees, and my reason is co-interior angles, and the parallel lines are EF parallel to MN. For the next question, once again, be careful to not use alternate angles because A, B, and CD are not parallel. So what else can we use? There is a F that goes this way with the parallel lines that I have. So that means that A equals C, which then equals 117 degrees. My reason for this is the F is corresponding angles. And the parallel lines are EF and MN. And for my last one, to find D, there's a little bow tie here at the bottom. So that means that D equals 94 degrees, and that is vertically opposite angles. And remember to say that they are equal. So once again, we can also include algebra when I work with my parallel lines. So over here, it is still fairly easy to see that this is corresponding angles. So that means that P1 and R1 are the same, and that's also what I write down. That's 3A plus 30 degrees is equal to 6A minus 60 degrees. So I like to take my A's or X's or whatever I'm working with to the side where there's more of them so that I do not work with negative values. So because I have more A's on this side, on the right, than on the left, I'm going to take all my A's to the right-hand side. So 6A minus 3A, so that's going to give me 3A. So I'm not working with negative A's, and that makes me very happy. So that means if I want my numbers on this side, then that 60 needs to move away from there. So remember, because it's negative 60, I'm going to add 60 on this side. So that gives me 90 degrees. So if 3 A's are 90 degrees, it means that 1A is 30 degrees. Great, and there I have solved that problem. But remember, don't be so excited to solve it that you forget to write a reason. So my reason was corresponding angles, and my parallel lines that I used in this case for the F. So let's just check. That was EF parallel to GH. In this question, once again, if I have to solve this alphabetically, I have to start with A, and in A, that really looks like angles round a point. What that means is that A plus 20 and A and 210 degrees, all added together, must add up to 360 degrees. And now we once again have an equation that we can solve. So I have 2 A's and 230 degrees must equal to 360. So that means that the 2 A's must equal 130 degrees, which means that A is 65 degrees. Always remember the reason. So this was angles round a point. Let's go on and find B's value. So with B, I can do co-interior angles. Once again, it's nice if you write in the value on your drawing, because that just makes it a little bit easier to see what you need to do. So B's value, I have to say 180 minus 65. So that means B is 115 degrees. My reason here, co-interior angles. And remember, my parallel lines that I'm working with in this case is going to be, remember, this is the leg of your co-interior, so the lines there are BA parallel to, oh goodness, I don't know what this point is called. Let's just call it CD for now. Okay, so I found B's value. Now let's see if we can find C's value. So either you can say that these are opposite angles in a parallelogram, or you can use another co-interior angle like this. Okay, and in this case, I'm working with these parallel lines that go this way. So that means that C's value would be 65. And I'm going to use my reason as co-interior angles. You can also use the reason of opposite angles in a parallelogram. Okay, so now the parallel lines I'm working with is, let's just call that D again, is parallel to AC. If I need to find D, I can use corresponding angles. This is an F on its head over there. So that means that D is the same value, that's 65 degrees, corresponding angles. And in this case, I'm using these parallel lines. So that's CD and BA. And for my last one, to find E, I'm just going to use angles on a straight line. So that is going to be 115 degrees, and that is angles on a straight line. So I've mentioned properties of a parallelogram in our previous question, and they can be very helpful in solving questions where we have more to do with quadrilaterals. So make sure that you know all these different properties of a square, a rectangle, a rhombus, a kite, a parallelogram, and a trapezium. And you also need to know that the sum of angles in a quad equal 360 degrees. In this first question, they tell you that it is a rhombus, but they don't actually give you any of the properties of a rhombus on the drawing. Therefore, you need to go and fill it in. So hopefully you know that all the sides of a rhombus are exactly the same. So that almost gives us a lot of two isosceles triangles that we can work with. The other thing that you should know is that the opposite sides are parallel, so we might also work with that. And once you've filled that in on your drawing, it becomes fairly easy to figure out the rest. So for this specific question, I'm going to use the fact that this is an isosceles triangle. So what that means is that angle C2, which is the x angle, is equal to A1. You can even say it's equal to x. And once again, angles opposite equal sides. Now that I have that, I can work with the interior angles of a triangle. So I can say that x is equal to 180 degrees minus 50, so that gives me 130, divided by 2, and that gives me 65 degrees. Because remember that I have x and x here are the same, so 65 and 65 and 50 must all add up to 180. So my reason here is interior angles of triangle. Just like in the previous question, they tell me that this is a parallelogram, but they don't put any of the parallelogram's properties in on the drawing. So I'm going to start by saying I know that these two sides are the same and they are also parallel. Also know that these sides are the same and they are also parallel, because that might help me in the future with solving either x or y. One of the first things I notice here, though, is that I have vertically opposite angles. So here in the corner, I have a purple bow tie, and that is going to help me to solve for y. In this question, they tell me that ABCD is a trapezium. And they're also kind enough to tell me that AD is parallel to BC. So that is not put in on the drawing, so you can go and put that in straight away because that will most likely help you. And we are most likely going to use funsies for that question because they tell us that those lines are parallel. They also tell me that AD and BD are equal in length. So that means that this is an isosceles triangle over here. And they tell me that BC and CD are the same. So we have another isosceles triangle over here. No doubt we are definitely going to use something to do with isosceles triangles. Only one angle is given, and that is the 78 degrees over here. And we need to find all the other angles. So always start where the angle is given. So this is in the purple triangle, so I'm starting in my purple triangle. There's also a very good chance that we once again have to do this in alphabetical order. So I know that A is also 78 degrees. Why? Because they are the two base angles of this isosceles triangle. And they are the angles opposite the two equal sides. Great. Also good to fill it in on your drawing because that normally helps us just to see what is happening. To solve B is very easy because it's interior angles of a triangle. So that means 180 degrees minus 78 minus another 78. So B's value is 24 degrees, and this is interior angles of triangle. Also filling that in on my drawing. So one thing that we haven't used yet is the blue isosceles triangle and the fact that the two lines are parallel. And the fact that they are parallel is exactly what we're going to use next. Because look, there we have alternate angles. So C is also 24 degrees because those two sides are parallel. So that is alternate angles because AB is parallel to BC. Now that I know that C is 24 degrees, what do I know about this isosceles triangle? Is that C and D are equal. Therefore, they are both 24 degrees. As always, good to fill it in on your drawing because this is the angles opposite the two equal sides. And now to find E is going to be very easy because I have to say 180 minus 24 minus another 24. And that gives me a value of 132 degrees. Our reason for this is int angles of triangle. I hope that these few worked examples gives you a little bit more insight into angles, lines, and triangles. Remember to keep on practicing because the more you practice, the easier it will be for you to see it. Also remember to use your highlighters and your drawings to make your drawings come alive and see the different parts of it a little bit easier.